Hi everybody. This is a new CAD tutorial that will focus on modeling a 3D printed friendly flashlight. I will continue the other series as there's still some educational value there, but let me focus on why I'm making this new series and why this flashlight that I'm showing you here is more 3D printer friendly. So if I show you the previous one, so if you were to print this out, you can print it out in two orientations. You can print it out horizontally, so you can imagine where I'm drawing this line to be, uh, the bottom of the printer, right? So you're printing there, and it's going in this direction, and it's going layer by layer. So as you're doing that, you're adding a bunch of support material here as the print progresses. And another version or another orientation is you print this being your flat side, and your orientation for the printer is going up. And so here you're printing layer by layer, but once you get to this component right here, you're also printing out so much support material, and then you finally start printing something from the actual design. So it's a lot of wasted support material here. As opposed to this design, here with this design, you can print it. So if you print it vertical orientation, you're still going to run across that problem, right? You're going to get all this overhang right here, all this support material that you have to print. If you print it this way, you can see there's a lot of empty space, so support material there. But if you print it from this side, and with your orientation going upwards, there's not that much support material you have to actually print. It's just going layer by layer. There will be very little support material being applied right here where this hole is, and also just a little bit of support material, not as much, but that's fine. So something like this would be preferable. So let's go about how we model this, right, on OnShape. So I was telling you on OnShape, or whenever you're CADing, you always want to start with your big features. So your biggest feature being, I would say, this prism shape. So you can do it two ways. You can do your prism shape this way and print it out, or not print it out, extrude it going into the page, right? Sort of like that, I suppose. It's going into the page, right? You're doing this backside and you're going that way, or you could go this way, right? Print out this prism shape, and then also imagine you're going into the material. So the print would be going this way, right? Your rectangle's on this side, and you're going in. So I would prefer doing this version. In my opinion, this would be preferable as opposed to this, because with this, you can specify your origin, right? And having your origin in somewhere sensible makes the assembly process simpler, in my opinion. So we're going to do that. So let's go over to OnShape. I'm on OnShape, got revision A, that's the old flashlight, revision B, the new flashlight. And if you want to make a folder, you just go to create, and there's a folder, give it a name, jump into your folder, same thing, but this time we're making a document. And I'm going to call it flashlight components. And now we're here. do want to add that how you manage this or how do you interact with OnShape, if you right click your mouse and you drag it around, you start rotating the 3D space. If you hold Control and right click and move, you're sort of just panning the design, and this actually allows you to rotate. So let's start sketching. I'm going to sketch on the top plane, right? And then let's get a normal view of the top plane. So now that we're here on the top plane, going to do a center rectangle and do it something like that. All right, so for starters, let's get the width and the overall length of the flashlight. So if we jump back here, let's clear it up. So we can get the width of the flashlight. So, oops, right there, we got the width. So shortcut, press D or press on this smart dimension. Click that, and so right now it says 1.21 inches. So our drawing, it specifies that the dimension should be in millimeters. So what I could do is just type in 50 mm. It specifies 50 millimeters. It converts it to inches. I'm going to go to workspace units, change this to millimeter, press OK, and then edit our sketch, and it still retains that 50. And let's dimension the overall length. So right here we got our length, 135.325. So let's dimension that. We can press D or dimension tool up there. And the rectangle, so over here or press R? Sorry, I glossed over that quickly. So our dimension was 135.325. Press enter. But the issue is that we're having, right? We want, whenever we're dealing with something on the sketch plane, we always want it to be completely black. It's still blue because this point isn't constrained, or these blue lines are constrained either. So when you do a center rectangle, it adds references. So it makes sure that this point is on the midpoint of this line and this line. And also, these lines have the same midpoint. So, this is centered across all these lines, midpoint there, midpoint there, there, and there. Also, it does a mirroring effect. So this point and this line are 25 millimeters away. So it's the same over here mirrored. Same thing here, this point and this point are half of that distance. Same thing in the other direction. But we want our origin to we want our origin to exist, somewhere where the LED will be. So I took off the midpoint constraints. So now, this moves freely, but it still has the mirroring aspects of it. So something I will keep is I will hold Control there, or click that point, hold Control or Command, or I'll click these two lines, and now we got relationships here on the top right. So we got coincident. So coincident just means that a point and a line, so constrain two or more entities to share the same location in a sketch. So you can see here, it's pretty much going to constrain a point and a line. So we don't want that. Concentric, it just has two circles with different radius share the same center point. Parallel makes two lines never intersect each other. Tangent, a line and a circle share a point. That's all that means. Horizontal, and make sure that a line is horizontal, or a point and a line are horizontal to each other. Same thing with vertical, just vertical orientation. We got perpendicular, two lines are 90 degrees apart, equal, same length, but we want this one, we want midpoint. So we click midpoint. And so now it shares the midpoint. And you can see it's horizontal to that and midpoint to that direction. So, I mean, actually, we don't even need this point. We can delete it. So we want our origin. That's the important object here. So let's center this origin to where the LED would be. So here we got, all right, so here's a good dimension to know, 108. So we got 108, but we want this point here. So that's over here. Here's an extra 2. So we know that from here all the way to this line is 110. So we click this line, click the origin, and we can type in 110. All right, and now this becomes an issue where we click on that point. So we click on that. So it doesn't like the midpoint constraint. So I suppose technically we should have kept the point on that midpoint. So now we got that point there. So we should have kept it beforehand. So we can click on these 2 points and make them horizontal. And now we got a completely black shape. And that's what we want. It's just having the origin on this location. It helps us later on because we know we're going to have a cone shape or diagonal lines here to make the interior cut. And so now here we're going to extrude it, but I like dealing with this side, so I'm going to flip it onto the other side, and it's going to extrude 25. So we can imagine we drew on this plane, and we're extruding, adding material 25 downwards. And it already has 25 millimeters, so that's perfect. We click green check mark. And so now we got the overall shape of the flashlight. However, we are going to start doing the cut into the flashlight. So if we go back here and just get rid of the highlights. And so here to focus on making these. Okay, this is annoying. You can imagine we got to make these horizontal lines. Let me just turn that off. Okay, let me try this again. It's working. All right, so we're gonna come here and we start a new line there. All right, so we're gonna do this general shape here. We're gonna go this direction, zoom out. So, I mean, you can see here, we can see, okay, we should go around this. And so we can revolve around that. But as you can see here, it doesn't really follow a round shape. You know, it's more of like a square. So we can't really revolve that. We can revolve it, but then you still have to add um, whatever's left of the circle, right? So if I draw a circle here, just to show you an example, right? This is my center, and let's shrink that down. Right, that's my center-ish. Shrink it down some more. So this isn't the best way to show you. Okay, you can kind of see what's going on here. If we drew a a box shape right here, right? That will follow basically this shape. So you're going to be extrude. So as you revolve, you're going to be adding. Imagine this line right here that I've just made, right? It's adding material all along this. So you get to a point where um, you can imagine this just all being a solid material. So here, there's empty space. You have to get to a point where you get to remove that empty space. But then again, you could um, make this flashlight your own, and you could continue on. So if you have some prior CAD experience, you could just make this a rounded hole instead of this like square cutout hole with fillets. But I'm going to stick to the drawing, but you guys are free to make this flashlight your own. So let's go back here. Right, so we have this these lines. So imagine it's going to go that direction. Actually, let me increase the thickness. It's a bit easier to see what's going on here. Right, and let me continue on. So here you have, another line there, and a long line there. So you can imagine you make this general shape, and then you can, revolve it. Also, if you wanted to, you could make a fillet here, right? So, just imagine making a fillet shape here, right, to match what we just, what we're seeing here, instead of making it squarish. But something I want to put your attention to is right here. So this one isn't so easy to spot. You can see here, it's gonna try to follow this shape, but you gotta fillet here. So we do run across an issue. Actually, it's better if I show you why this won't work, but I'll just briefly explain what the issue we're going to run across. So if we make this a pointed edge, right, a pointed edge, and then we apply a fillet, it's not really going to accomplish what we want. because you can see here in this orientation, this fillet wouldn't be caused by a rounded edge, right? You can see that the cone is still flat all the way through, right? If it was filleted, it'd look a bit different, right? And you can see the fillet sort of stops. It just goes, it just curls up and stops. Same thing here. It's going straight and then curl down. And here's probably the best view. It's going, horizontal, and then it's curling up and it stops. If this was a pointed edge, you would see this fillet start at a 45-degree angle this way and go completely 90. But it starts at this 0 degrees and goes 90. So you can imagine a, a right angle here, flat and then straight. So just a 90-degree curve. Other version where it would be 45 degrees, sort of this way. I'm going to show you here. So right now, curve starts this way, and then it goes this way, right? It goes left and then up. If it was a pointed edge, you would have your curve start this way, and then it go 90 degrees, right? So instead of finishing vertically, it would finish, right? It'd go, it would go flat and then round, and like it would round around there. So let me show you shape with that. So what we could do is we click on this top line. So we know we want a flat line going across, right? So a flat line. So there's a cool tool we can use. It's called the Use, right here. So Use, it projects lines onto your sketch. So if I can type in U, you can see there's a line generated automatically. And then we got a flat line going down. So we click on L, and we got a flat line, some type of line like this. A line downwards, there, and there. And then now we're done. So that's the general shape. And then I'm going to add a construction line because we know we're going to make this revolve. So construction line, and then press Q. So let's dimension some stuff that we know. So right here, 9.5. So dimension, press D, click on those two lines and make it 9.5. What else can we find? Right here, 50 degrees. So vertical and then to that line. So to do that, we press D, we click this, and some type of vertical line. So there's a vertical line. So make it 50. Something else. I mean, this is going to make our hole, right? So distance away, here we got 5.5. So we know that we can dimension, this line to this point and make it 5.5 divided by 2. Okay. Okay. There's let's delete that for now, and we'll fix what's going on later on. Oh, I see why. So here it's making a driven dimension. So when it's grayed out, that means as you change stuff, this is gonna stay, it'll change based on edits. So it's right here, you can change it to a driving dimension, right? But we run into errors and then make it a driven dimension. And so another thing to add, because this blue line right here, you can still drag it left and right. So we got to find something that dimensions that. So for something like that, right here, we got this dimension right here, 2, the width right there. So we can press D and make it 2, enter. So yeah, let me, I see a better example. Remember, right here, this goes, right and then down. Same thing here, it goes left and then up, right? But it's sort of just the rounded shape stops abruptly, right? Because you have this cone shape. You would imagine, you should still see, if it was pointed, you would still see a completely rounded edge here. But here, you got a completely rounded edge. And it's facing out 45 degrees and it's completely rounded, and there's no, stop or jump discontinuity. Here, there's a jump discontinuity. It just goes left and then down instead of going left, down, wrapping around that flat line. And then you can see this line is not, because we have it constrained to that top edge, it's not allowing us to make this 50 degrees. So if we change this to, driving, you can see we get some errors. But if we go here, so let me just change this to driven. We want this point right here, we're gonna delete that. Or we click on it and then backspace. Now this line should be able to move. Still not letting us move. I mean, I can keep that. I don't really want to keep that there, or I do want to keep that there. I think the best way, just to trim it. So M or trim tool, just trim it down. And now if I was going to make a line to go like that, and then now, so I forgot to make these coincident. So this is a good example of adding the coincident. So see how that worked there. And now we can dimension this 50 degrees. And look at that. It constrains everything and it leaves us with a little bit of space there. Now we can make a straight vertical line. And if we want, we can add a dimension there. And it's pretty close to 1. But you can see 1 breaks it. It should be 1, but I'll leave it as that and change it to a driven dimension. Right, so now we got that general shape, but there is one issue. This is a material that stays, right? The opposite is what's getting removed. So let's keep drawing lines from here all the way there. And let's trim these lines as they're not needed. Trim that. We got a line that goes all the way there, goes up, escape, dimension. We can dimension this edge, 9.5, enter. So this is what we should have been CADing all along. This is what matters. This is the inside of the shape of the flashlight. And so another neat trick, we could also add the fillet right here. So right here, sketch fillet. So we can add that fillet. Radius 5, right click, press enter. And so now, fillet's there, and we don't have to do it later on. So let me show you. So right here, there's a fillet. And you can see the dimension of the fillet. It's going to be right here. So R5 radius, and it points to this fillet right here. And now, right, we got everything we need. So now we can do revolve, remove. Revolve axis is this. And look at that. It automatically detects what we want to do. Green check mark. And we got something solid now. And then I will show you the fillet feature. So right here, so we could have added the fillet feature here, but let's do the fillet here. Remember, it's 1 mil. Let's click all around. So you can see it's present top, bottom. It's present on the, here, you can see here, this dash line, represents the fillet edge. And you could also see it here in this orientation. It's going all across. And preview right here of the fillet. So if I just press green check mark, we can see that our fillet looks exactly as it does on the drawing, right? It goes left and down, and then it stops abruptly there. Compared to this right here, it's going all across. Here, left, right, you would expect it to round here, so you get like a completely rounded shape, but you're not getting that. So we got what's exactly in the flashlight. We could also continue on. Let's do the battery separator. So right here, there's a battery compartment, right? So there's a little box here. This holds a switch, and this will hold the battery. So let's just do the walls here. We'll call it a day and continue on another day. So right here, we can immediately see some dimensions relevant for the wall. So from this backside to the start of the wall, 58.5, thickness of the wall, 6. We could also see here the depth of the cut, another 6. So the way I would do it, I would sketch on this plane, click on that plane, normal. So normal is N, shortcut is N. And now that I'm here, I would make a box. So I would do a corner rectangle, box, doesn't really matter. I would dimension this line to this line, make it R58.5, press enter. But you can see it's like, why did we move to the left? It just does that sometimes. So you just click and drag it, click D, and then dimension this to 6. So what we're doing here is we're going to make the whole thing, and then we're going to cut out what we don't want. And so now we're going to extrude, add, instead of blind, we're going to go up to next, and flip the direction, and see that this is exactly what we want. Green check mark. Now we're going to sketch and sketch on this plane, and then I'm going to click that plane, press N to get a nice side view. Here we're going to get a rectangle, and we're going to sketch the rectangle we want. But we're also going to I'm going to add a point and make sure it exists on the midpoint. I'm going to click that point, escape, control Z, Z, all right. Click on that point, hold control, click on that point, and make them horizontal. Let's try that again. Let's click. So for some reason, in this orientation, it makes sense. You can see you got an axis here. So this is your horizontal axis, and this is your vertical axis, but we're flipped 90 degrees. All right, so now we're upright. So this is horizontal, and this is vertical. So we should have, I'll click that point, hold Command or Control, click that, and now make them vertical. And then this was a depth of 6. But now, this could move freely like that. We don't really want that. We need to find that dimension. We got to find out the thickness there. Let's try to look for something relevant. So here, 0.5 from this edge to the edge of the hole that we make. So we're going to dimension. Press D. Click on this line. We click D. We can click this point and this point and make it exist. 9.5. And that's what we want. And now we do the extrude tool, but we're going to remove. Instead of blind, we want it to be up to next. Because if we do blind, right, just for example, if we made it blind and we had done some other material here, it wouldn't know that, so it would just remove it. So we always want it to be, just what we want. We don't want to, you could do blind and then do these, what would be 6. You could do that, but in the future, let's say for some reason you make this bigger, in the other dimension you made this a thickness of 7, but you forgot to change this edit from 6 to 7, you would see that there would be a 1 millimeter thickness wall left there. And so this would require you changing 2 things in order to make it, work. So if we do up to next, no matter in the other sketch, if we change this thickness, it's going to always work.
I'll leave off the CADing here for today and continue on the next video. For now, get up to speed with the current CAD and feel free to ask questions down in the comment section below. I'll try to answer them as quickly as I can. I'll also include a link to a drive folder containing the flashlight drawings down in the description. Lastly, remember to have fun and take care.